Welcome. I want to talk about speed and velocity in this video. Velocity. These are probably two very familiar words from everyday life. If you run faster, you have a greater speed or velocity. If you walk slowly, you have a small speed or small velocity. But as I've explained in an earlier video on vectors and scalar, if you have watched that, you would know the different way in which we use speed and velocity in physics. That speed is a scalar, meaning just a number without any direction, and velocity is a vector, something that has a magnitude and a direction. So let me start by defining speed. Now in physics we often talk about defining something or a definition. Now the word definition, if you study physics, you're going to see this word very often, and we must always remember the definitions of some terms in physics. Okay. Now the thing about definition just means a very specific and clear meaning of a term that is often used in physics, like speed. Right. So what would be the definition of speed? Okay. Now speed. Write this down. There are any number of ways. There can be a few ways to write down this very clear and specific meaning of speed. Now a very simple way to write it would be just to say that speed is the distance traveled per unit time. Distance traveled per unit time. Now that's one possible way to describe it. Now another way we could describe this, we might as well get used to this, is slightly more difficult to understand in a sense. I'll write it out and explain what I mean. That should be version 2. If you like, that's version 1. Version 2. Speed is the rate of change of distance. The rate of change of distance. Now the rate of change of something, simply means how much it changes per unit time. Now I realize that I've not exactly explained what we mean by per unit time. Per unit time might mean unit literally means just the number 1. That's what unit means. But when we say unit time, it refers to one of a certain unit of time. It can be any unit. Like for example, it can be 1 second. It can be 1 minute. It can be 1 hour. It can be 1 day. It can be 1 week. It can be, you get the idea. 1 month, 1 year, 1 century. I can go on, right? So it can literally be anything. But so But that seems just confusing. If it can be anything, then what is it? Right. So the easiest thing to do would be to think of an example. For example, I can say that speed. I can say that, let's say I'm walking with a speed of maybe 0.5 meters per second. 0.5 meters per second. So in this case, my unit time would be 1 second. Or you can say that the car is driving at let's say 30 kilometers per hour. 30 kilometers per hour. And in this example, 1 hour would be my unit time. Okay, and for example, the sun. Now let's see. I want to talk about distance. Okay, so the sun is a bit big a distance to think about. Right. So I hope that is that clarifies the idea of a unit time a bit. It just means that it's per some unit of time that you prefer to use. Okay. So as long as you can write down, as long as you can describe the speed of some moving object, can be you walking or can be a car moving, as some number of some distance, again it can be meters or kilometers or inches, over some unit of time, then you have the speed. So distance traveled per unit time. But what do we mean by the rate of change of distance? Well, as I said, rate really means the same thing as per unit time. Now, but there is something subtle about this word rate, because the describing it as a rate allows us to think about how fast something is moving at a certain instant in time, even when there is no time interval, like a certain amount of time over which the distance has moved. I'll talk about more about that later on when I talk about instantaneous speed. Now, coming on to velocity. Velocity, as we use it in everyday English, we just think about it as the same thing as speed. But as I explained in the video and lecture, it's really a vector, and it comes with the information about comes with information about the direction. So let's say I'm walking. Okay, let's say that's the east and that's the north. Okay, and one morning I decide to take a walk in a certain directions, let's say, which is at this direction of 30 degrees to the east direction, and I decide to walk at a speed of 0.5 meters per second. So I would write this as 0.5 per second. Now that's one way to write 0.5 meters per second. Another way I can write this is 0.5 meters and then s to the power of -1. So it's like doing algebra here, but the stroke here means the same thing as a divide. It's like meters divided by second. That's what the stroke means. It means something like, it means exactly like a fraction. So if you're dividing by s, it's the same as multiplying by s to the power of -1. So this is the notation, this notation comes from algebra, right? We're treating m and s as if they are variables in algebra. So you can write it either way, and both ways are quite common. In fact, this might be a bit more common in exam papers. Okay, so coming back to this, now if I'm walking at this speed of 0.5 meters per second and along this direction, what is my velocity? So strictly speaking, if you see a question that asks you this in physics, alright, if you see a question that asks you this in physics, you must give the velocity, you must give as your answer for the velocity both the magnitude and the direction. In other words, you must give both informations. Right, so you must say that your velocity is actually I write words is 0.5 meters per second. So that's my magnitude, and you must give the direction as well. Now, but how do I give the direction? Can I just say 30 degrees? Can I just say my velocity is 0.5 meters per second at 30 degrees? Now, that is probably not enough if you just say 30 degrees, because if you we must give enough information here so that people can tell exactly which direction you're going in. So if you just say 30 degrees, it could mean 30 degrees to the north, which might be actually there, right? So that's 30 degrees to the north. It might mean 30 degrees to the west, so it might mean something like that, 30 degrees, and that's not right. Okay, neither of this is right. You're actually walking at 30 degrees to the east. So I would have to include this information, 30 degrees to the east. Now, but if you've learned about bearings, you would know that it's not enough to say that, because 30 degrees to the east could be on the north side, or it can be on the other side as well. So how do we distinguish this? Well, you could say to the east on the north side. Okay, that would be perfectly fine as an answer, very clear, and all that. But if you want to be more concise, or write it in fewer words, you can use, say, some notations. Now, there are various notations people use to tell bearings. You can, for example, in this case, you can write N, which means north. Let's see. Oh no, actually, you might write. Okay, you might write, say, E for east, and then you write 30 degrees for the angle, and then you write N to mean on the north side. So that might be one way to do it. Another way to do it is that you might decide to use the other notation. That there is another notation that students often learn at this level, which is the notation for bearing, in which we measure angles from the north. So if it is 30 degrees to the east, from the east, then it would be 60 degrees from the north. Now, and in this case, it's 60 degrees from the northerly direction. If you measure if you're looking down from the top, that would be clockwise. So when you are 30 degrees from the northerly direction, clockwise, then we can also write this as, so this would be also equal to 060 degrees. So that's a notation that you might have seen, or that you might learn later on, for bearing, or to write down bearing. So either of these would mean the same. In fact, all three of these would be correct. This one, and this one would be perfectly fine. Or if you could think of some other words to describe it, as long as it's clear enough, it is fine. So that would be the direction information for the velocity. Now usually it wouldn't get so complicated. You could usually think of a way to describe it. But I know it means that if you are actually answering an exam question on this, it could be a bit uncertain as to how exactly you would write it. But don't worry, just try. Just remember that as long as you write it down clearly, with some practice, you get it right. Okay. So to emphasize the point again, to give an answer to when a question asks for velocity, you must always give the magnitude and direction. However, if you are talking about for example, certain exam questions, even exam questions might be a little bit less strict in the way they use velocity. So for example, now and then when an exam question asks for velocity, you may only need to give the speed as your answer if there's no other information about direction that you can find. Or it might be a multiple choice question that asks for velocity, but all the choices are just magnitudes, for example. So now and then you would find some examples in the exam question. But apart from that, we must always remember very strictly. We must always remember that velocity strictly means the speed and the direction of the motion.